So welcome to introductory video 7 on data visualization and of course ST1 describing data. Data visualization is very, very important. You'll see a lot of in different science papers, these awful bar graphs or dynamite plots that you see as well, where they put some sort of standard error here at the start. Don't use them. They're really, really bad. They hide the underlying data because they're looking at summary information rather than plotting the points for each of these groups. There's many options for data visualization, and you should think about them carefully for your data. You might need a cumulative curve, which looks at the rate of increase depending on one variable, or you might have box plots, which we mentioned already, if you have many groups. Or you may have a histogram where you want to look at the frequency depending on one particular variable. And you can think about how you want to change your binning approach here to represent your data more effectively. You might want to compare and contrast two distributions side by side, which is what is done when you have a population pyramid. You may want to summarize this in a different way in a continuous manner, like a violin plot, and you can even split this so you've got two plots facing each other. All of this can be done with R, so that's why learning to code rather than doing things with Excel is highly advisable. You can navigate things like how many bins do you want to use? Sturgis's rule is one example of that. If you have n data points, you can scale it by log base 10 and 3.3 plus 1. And that means that you can switch from this to this depending on what you want to do. In practice, what I find is that it depends. If you write code to do this, you can find that you can actually toggle this a lot, and that's what we'll do in this lab. It's also worth noting that if you transform your data, a linear scale is more easy to read because it's more intuitive. Because if you look at the distance from the edge here in meters, 1 to 100, and then the population size in kilos, having two different correlations like that are more intuitive between the black and dashed groups. However, if you log transform these, the relationships are still linear, but they're on a log scale. So that means they might look like they're both correlated with each other, when on a linear scale, these are actually not. So the studies, like the one shown here, suggesting that many readers interpret graphs correctly when the graphs are linear, but when they're log, only 50% can understand them well. So be careful with data transformations when you're representing data, and there's a legacy of studies that have mistransformed their data. So using the previous data sets on the infected and uninfected cattle, create a histogram using the function hit with a suitable of bins using the breaks argument that you can put inside hist. Then moving on from questions 15 to 16, repeat question 15 with the data log scale and exponential scaled, and add a grid with a grid. So you can compare the differences. Finally, for question 17, that's already present. So you can skip that one. So for question 15, you can look at this one where you're looking at the previous status of infected and uninfected cattle. Use hist with the pseudo number of breaks inside that argument to represent it in a way that you think is visually effective. So you can put that breaks argument inside hist. So you might breaks equals 14 or something like that. And then you repeat that question 15 using the data when it's log scaled and exponentially scaled. And you can add the grid function with grid. So look that up, and that's a handy one to have. So that completes our part in data visualization. So what we've looked at in this videos is that we've looked at the key statistical terminology and concepts in terms of looking at discrete data and thinking about sampling, experimental design, and data summarization and visualization. So now you're able to think about the data that you have, look at it, describe it before moving on to the next page of maybe exploring another sample or models of inference. So now we should be able to think about your experimental design, your sampling approaches, your data types, and your sources of errors most importantly. So please come to the labs where we'll talk about this in more detail.